I'm going to talk about doing some mobile DevOps on GCP. It's a bit of a unique talk that I'm kind of using some of the tools here to do serverless builds of Android apps and distribution. I actually will show some code and whatever, and if that's what you're here for, that's good. Might be one of the more technical talks, I'm not sure. So the first thing to get started is I'm going to talk about our little application. I've built a little application that's going to take the world by storm, not really, because I'm a developer and an ops person, not a designer. Some of the GUI's not that fancy. But I just built a little note-taking application, and the idea is we're going to simulate, we're going to build this application and continually iterate on it, make changes to it, and run it through a DevOps pipeline and see what happens. So little idea, this is the sort of sad GUI that we have going on. We can take little text notes, and we want to add image notes to our application, but they're not done yet. So we're going to merge a feature and see what happens. Hopefully y'all can see the text well enough. If you look at the bottom, there's like a little terminal window in Android Studio. So not a whole lot to see here, but what I'm going to do is try to merge a branch, a feature branch in here, and just go ahead and I'll make sure we've got lots of changes. I guess it auto-merged. And so I'm going to go ahead and push that code up to the repository. Wi-Fi is getting slower by the minute, I guess, as people arrive, but there we go. So that's all I'm going to do on the application for now. I can show it to you as well. It's just a little note-taking application. You can add text note, create a note, you can edit a note. Everything's stored in Firebase. And that's sort of how it works. Right. All right, so now let's talk about DevOps for a minute. You know, some lovely quotes here. DevOps is not a goal, but never-ending process. It is how sort of most of us by now, in the past like 3 or 4 years, are used to working. We want to get stuff, features in the hands of our testers or our constituents in the company, and get iteration faster, find the bugs faster, shorten the loop. And so in this, what I'm going to demonstrate is a dog fooding sort of pipeline where we're building and testing internally, developing, pushing stuff to the repository, and then sending out apps to our dog fooders. What dog food means at Google is sort of folks internally testing our applications before we release them, which I think is a fairly common term in industry. And so with mobile, DevOps is a little bit funky, right? Because we have, unlike web, we've got to like sign this binary. We have to create the binary. We have to sign the binary. We have to get the binary to the users, and they have to install it from somewhere. And there's lots of extra stuff going on there that's not like web. We can't just sort of build a new Docker container and launch it into Kubernetes. We have to actually physically deliver a binary to the mobile user. But we can still do that using this fun new product, old product, renamed product called Cloud Build, which was originally termed Container Builder and meant to be used to build, Docker containers and maybe, deploy them to Kubernetes and things like that. It turns out what we learned about Cloud Build is that we can build anything, and the community sort of taught us that the most. I mean, there's a cloud builders repository, which I'll show you, that has many different types of builders for cloud build. But back to mobile DevOps. So this is sort of a flow for mobile DevOps, right? We trigger some build. We test the build, at least a smoke test on the build, and distribute that binary, and then maybe we monitor for crashing or other analytics. So it starts with developers, hopefully starts with a repository where we're all putting our code in. I think that's pretty known commodity nowadays, but if you're not using a source code repository, you probably should look into that. And then we're going to trigger a cloud build process. And these are the repositories currently supported by Cloud Build. You can use Google Cloud Source Repo, which I'm using here, GitHub, or Bitbucket. This is what it looks like to create a build trigger. There's basically 3 steps. You pick out the source control repo you're using, you select the specific repository, and then you set up your trigger. When you set up your trigger, you can pick out a branch. You can obviously name your trigger, pick out a branch, and or a tag. So you can trigger based on tag. I'm using a branch here, kind of a la git flow, but you could just as easily use a tag, which might actually be a little bit better for your specific case. And this is how you trigger the build, which is what I just did. So building the binary, again, we're triggering a build in Container Builder, or Cloud Build, rather. I'm going to mess that up a lot. And that build is described by this funky magic file called cloudbuild.yaml. And that is what describes every step that you want to take, just like you would in your, if you're in Jenkins and you have like a list of steps, you'd have that. This is the description of the list of steps that the Cloud Build will take and in order to build your binary and test it and do whatever else you want to do. And in this case, we're going to push source code, and the steps are going to be described in the Cloud Build YAML. And after the result of our Cloud Build is going to be a distribution through Fabric or Crashlytics Beta, which is going to end up emailing our users about the new application. Ooh, that slide didn't show up right. Sorry. OK. So the Cloud Build workflow is, again, a bunch of steps that operate on your workspace. So when that trigger happens, Cloud Build pulls the source code and drops it all in a workspace directory, just like Jenkins. That probably sounds familiar to anybody who's used Jenkins. And then it runs a bunch of build steps. The thing that's interesting about it is that all of those build steps are containers. And the commands therein are sort of contained, all of their dependencies are contained in Docker containers and images. And so in this case, we're doing a gsutil copy stuff from cloud storage, an Android build, another test using the gcloud command, and some more Android build. And that's all, each one of those steps is its own Docker container. So you're actually calling Docker run in order to complete that step in the workspace. And like I said before, there's a rich set of those containers in the community site. You can find stuff. The Android container is the one I'm discussing here, which is contributed by me, but it's open source. So if you have like edits and PRs, you can issue PRs to it. But there's, as you can see, a ton of different containers for doing builds and deployments. There's one for instance, create, G-Cloud, you can create compute instances and everything like that. There's one for kubectl if you're deploying, Kubernetes manifest, deploying Kubernetes infrastructure. And there's one there that's called Dataflow Python, which is you can imagine is meant for setting up a Dataflow job. So there's just lots of possibilities. So in using the Android builder, what you're going to do is build the container that's going to run the Android build, right? So it's going to have the Gradle and Java SDK and the Android SDK. And in order to build that up, what we want to do is we want to build a container that's lean, relatively lean, so we're not, we don't want to necessarily include every Android SDK from the beginning of time to now in that Docker container, because it's going to take a really long time to pull that from the registry. So in order to sort of semi-customize and package an Android builder for your own needs, you edit this packages.txt file, which specifies all the packages you want in your Android builder. And every time you use the Android builder, you can change, or every time you create a new Android builder, you can change the packages you're using. Now, the Android builder also requires you to supply your license key from your workstation. So in your Android SDK home, you're going to have like a licenses directory. So you can supply your Android SDK license from there as a build substitution in Container Builder. I'll show you that in a minute. But so each of these would have to have the EULA already accepted, and then the license key hash that you supply to Container Builder will already know that you have accepted the license, and it will continue the build. And so after that, this is sort of the steps. You clone the repo, you create the packages .txt file in that directory, and then you submit the Android builder's cloud build YAML file, which is going to build a container in your Google Cloud's container registry that's going to have the Android builder piece. And you can just go ahead and call that from your app's build, which I'll go through. So that's sort of the 3 steps. And then you'll have, the result is you have this Android builder in your registry. If you want more information on the Android builder and like more specifically, there's a document drafted by me on creating this pipeline in more detail on our website. So you can hit up this document, and it goes through all of the steps for setting up the Android builder. So you don't have to sort of remember everything that I'm saying here. I'm just trying to give you sort of an introduction. But here's some more details that you're probably looking for. So in getting more detail about what we need to do to build the mobile app, we are going to need to sign the Android application with a key store file, right? Everyone who's an Android developer probably is familiar with that. And so the way we approach that in this is we just go ahead and copy all of the signing information to a storage bucket. And that storage bucket will only be accessible from the project that you're using to build. And you could secure that even further with key management, but sort of out of scope here. You copy your Fabric secrets up to a different bucket or to the same bucket. And there's an extra little optimization here called the build cache, which sort of tries to optimize the dependencies for Gradle, so it's not downloading the internet all the way from the internet, but maybe downloading the internet closer to where Cloud Build lives. And then we move on for our test items. The other thing to note here is the arguments in each one. Those are actually arguments to the Docker run entry point. And you can change the entry point. None of these actually change the entry point, but you can change the entry point on these containers to just sort of execute arbitrary bash as well. And still have, for instance, let's say in the gsutil, I want to just do arbitrary bash. I can add an entry point in there, run that bash, but that bash still has gsutil in the path for that command. So that bash command can call any of the dependencies from the gsutil container, for instance. So this is sort of how you put together a build. The other thing to note here is the substitutions we have. Any of these shell variables with a underscore in the front is what we call a substitution in Cloud Build. And what that is a value you supply when you configure the build trigger. So you can update, you can basically parameterize your build. So the signing API secret bucket path is where to find fabric.properties in cloud storage. It's actually a GS URI, gs://URI. The license is whatever you copy and paste it in for the license. There's a new version pending, by the way, where you can copy all of your Android licenses to another bucket and use a bucket reference instead. That's a PR that's been submitted and currently pending. And then another parameter to mention here is wait for. Wait for is how you wait for other things. So you need your signing files, obviously, before you build the distribution version of the app. And so you're going to want to wait for that copy to complete before you build the distribution file. Also, you need your, well, I'll have to go on to the next slide to show more dependencies, but you get the idea. So after we built the binary, so in this one we build the debug version of the binary, and then we're going to test that debug version with Firebase Test Lab, which is a service that we provide, that Firebase provides, that has actual physical devices in a data center that you can run both robo-tests and functional tests on. This pipeline specifically deals with robo-tests, but you can also create Espresso, record and create Espresso functional tests and run those tests on the devices in the data center. So it lets you run detailed tests, and you can see the results and add workflow and et cetera. Oh yes, let's take a look at the devices. Okay. So here's I pulled up a list of devices recently from Test Lab. So these are the devices you can actually run your functional and robo tests on. There's quite a few of them. Some of them are virtual, you'll see, but most of them, the vast majority are actual physical devices that your APK will be loaded onto. The debug version of the APK will be loaded onto and tested, or the test APK as well if you're using Espresso. Switch. Yeah, and so here's our workflow again. Okay, so the Test Lab build step is interesting. So here is where I had to use the bash notion of, I'm running gcloud, but I'm going to wrap it in some bash to make sure, because the Test Lab command in gcloud doesn't give me a good status process exit code when test pass or fail. So I've added some fanciness here to check whether the test passed, and there's a grep statement further down. But you can see more of the wait for up here in the build. So you can see some more of those wait for arguments. And this is sort of like some screenshots from a robo test. I can actually flip over to the other laptop and show you some of the output of a robo test if you're interested. So that here you can see this is some of the flow of a robo test is kind of like a random touch and type test. And you can see I'm using Firebase auth. I know this is a little small. I can get into some screenshots. But I'm using Firebase auth here, which uses Google sign-in. And actually, this thing comes up with its own Google account and signs in to the app, and then starts touching different aspects of the app just to see if anything crashes, right? So let's say like this create button was enabled in here. Then when the robotest hit create with an empty string, it might have like caused a null pointer. And if that happened, the test would have failed. So and you can also get a video recording of your robotest. So you can go through and see what the automation did. And this is actually on a pixel. Yeah, so it's getting the OAuth screen and then it's saying yes, and then now it's got it open. It's a little flickery with the video, but you can see sort of what different screens it's accessing and all of that. Trying to it's sort of like a blind person just trying to break your application. That's the best way to describe it. You can flip back. So the rest of the build is trying to distribute assuming the test pass, right? Assuming there's no failure in the robotest, we're going to want to send it out to dog fooders for the folks internally for further usage. And so that's what Fabric Crashlytics is used for. And this is, in this case, I'm using just Gradle, a Gradle command for that. You can actually use Fastlane here, but Android developers still like Gradle, I think. Some are converting to Fastlane, I'm not really sure. But this is, suffice to say, a Gradle implementation. So a couple things to note in this part of the build is that we're wrapping the Gradle command with a script that does like that fancy grab the cached jars from the storage bucket, and it copies the licenses over that you supply. The other things you see here are substitutions. So the build type is the beta build type in this case, and the email distribution group is the set of folks in Fabric where I want to email the build to, and the upload distribution build type is the thing that actually uploads the APK to Fabric or Crashlytics. And then once that is uploaded, once that's completely uploaded, your users that are your testers will get an email notifying them that there's been an update to the application. And so this is sort of what that tester UI looks like. You can add emails for different applications you might have and pick out which of those groups you want to email your results to. And you can have different ones. Maybe you have different build flavors or different build types, depending on who in the company. You might have some that just go to developers, some that go to QA after that, some that after that might go to product managers, and then maybe finally the whole company. So you can really like granularly adjust that. Finally, what we do here is this is Crashlytics, and this is actual bug that I had in the code. It's hard to see the stack trace, the Kotlin stack trace, but I had a bug with my Firebase access, and this was one of the notifications I got from Crashlytics of the crash. So you can, once this thing's out in the wild, or out to your users, depending on who they are, you can monitor for crashes. So this is sort of like a full serverless pipeline where, everything is done using managed services. There's nothing here that's sort of an online thing you have to keep up and running. There's no sort of Jenkins server. There's no Kubernetes cluster to keep up and running. There's nothing to maintain. It's all sort of, when you submit that new cloud build YAML, it boots up that container and starts running all the Docker commands. So that's sort of the use case here. Just a minute, I'm going to. Right, so a few minutes ago, I issued a build, and we can see the results of the build. It was successful, and this is sort of what the output of our pipeline looks like here. You can see each command, and so this is running Ubuntu is just an arbitrary shell running container. So if I use Ubuntu, I can just call like make.dir or whatever, stuff like that. I've got a copy licenses step, and I can just page through here. I'm not going to go through everything. The test lab one is interesting. You can see that this one takes a bit of time, 5 minutes to complete, which is why I do that at the beginning and then wait until it finishes. And you can see finally that at the end of this, there's a whole nother build, and it's finally, at the end, it finally sends it up to Fabric. So there's actually 2 Gradle builds that happen in here. The first one is a debug build for the robotest, and robotest takes the debug APK and does its testing on it, and then finally it's pushed to Fabric. And then from there, I get an email, hopefully, if I can get my beach ball to stop. There we go. I should get an email to my user. I'll just go on the oh, I should have got an email here. Interesting. Maybe I'm not sending it to this one. Okay. Yeah, so from there, my users would get an email, assuming this guy's a tester. Maybe he's not sure. Should have one on my phone. Okay, I have one on my phone. Let's see if is it just this one? Just pull this out. Oh, here. Yeah. So yeah. Oh, can we do this? What's that? Oh, you don't have it? Oh, okay. Well, will it work if I just pull this out and put it here? May. And they're really connected to Android before. Anyway, on my phone, if you're really interested, I have an email from Fabric with the new version. And we can also take a look at the robo tests that occurred, hopefully. Right, so this is the last set of robo tests that just completed. And right, so they look pretty much the same as the other ones. But you can see that this one just happened about 20 minutes ago. And yeah, so that is, in a nutshell, how to do serverless managed DevOps with Android on GCP. It's cloud build plus Firebase Test Lab.